Yes.
Dr. Sagan, are there any...
Could you identify yourself, please?
Pardon?
Could you identify yourself?
Yes, Jim Scheuer, former member of this glorious body.
And an old friend.
In which I spent 26 extremely happy years. Can you, and served on the Science-Based Technology Committee for many years, can you suggest some you didn't think much of that list of 5 science projects, mega projects that you heard. Only 2 of them you considered science projects at all. Can you give us some other tidbits? Can you whet our appetite for significant science projects, maybe that don't come in the mega science category, maybe smaller projects that still have great potential for contributing to human well-being?
Jim, I would say that the very fact of asking, as the people Sherry was talking about did, for a list of extremely expensive projects to do in, quote, science, misses an essential point. And that is that a great deal of the most important science comes in ways that no one ever could predict. Comes from supporting small projects, graduate students, independent research, people who don't have any practical application in mind, but just one thing leads to another. So all through the sciences today, there are problems in which established scientific investigators can't get the money just to keep doing what they've been doing, in which young scientists, recent graduate students done extremely well, gotten their PhDs, now they need some money to pursue their science. The money isn't available. It's young people, you're on your own. We don't have enough money. And as more money gets poured into specific projects, and as the National Science Foundation is directed to spend more money on particular programs that reflect the national need, there gets less and less available for fundamental research, and it's a very dangerous trend. These should not be alternatives. We should, if we're interested in the well-being of the country, and science and engineering are important aspects of it, then it's essential to support the research of young scientists. Let me try to give just a flavor of why this is important. Look, here we have a public address system. There's a television camera. Here are incandescent lights. Give us a sense of the technology all around us. The food was refrigerated before it came here. Now, where did all that electrical technology come from? Suppose you were Queen Victoria's science advisor, Jim. And this is bizarre on many levels, but imagine she came to you and said, this one, Queen Victoria's science advisor, is not available. Suppose she came to you and said, you know, what I would like is a kind of box in which there could be a moving picture that I would be sitting at Balmoral Castle, and somehow the picture of me would be in a box in the home of every British citizen, and that would help run the empire, or whatever she would say. I mean, suppose such a bizarre request were put to you in 1850. What could you do about this? Could you have a crash program, a Manhattan Project to develop television? No way. It just, the science was not available. But meanwhile, in that same rough period of time, there's a Scottish physicist named James Clerk Maxwell. And what he's doing is looking at experiments on electricity and magnetism done mainly by French scientists. And he tries to write down equations to sum up their results. And there's 4 equations, and he looks at them, and they are aesthetically displeasing. They don't have symmetry, and he thinks they ought to. So for aesthetic reasons only, physicists call this intuition, he added another term to make it all look nice. That additional term is called the displacement current. With that in, you discover that moving electrical charges can generate light waves, and from Maxwell's equations comes much of modern technology. Now, Maxwell did not intend to do anything having to do with the technology. He was interested in how electricity and magnetism works, and just one thing led to another. Now, that's not a justification for any scientist to request money to do anything. You know, there's good science and bad science, and you have to make decisions, but it's important to remember that the most vital findings often come from somebody you never expected, from some line of work that seemed to have no applications at all. Moving electrical charges, who would have figured that it would come out of that? And that's why I would urge organizations that spend money on science, National Science Foundation, NASA, and others, to remember that it is absolutely essential to support many small projects, especially for young scientists.